Hey, sixth grade. I hope all is going well. Today for math, we're going to talk about time around the Earth. This is going to cover page 275 and 276 in your textbook. So in 1 hour, the Earth rotates 15 degrees. In 4 minutes, it rotates 1 degree. Remember, there are 360 degrees in a circle, so since that 1 day is 24 hours, that's how they come up with those numbers. Meridians of longitude run north to south. 0 degrees longitude runs through Greenwich, England, and is called the prime meridian. Greenwich Mean Time was the basis for time around the world until the 1970s. Now we typically use Coordinated Universal Time, abbreviated as UTC, which is based on the atomic clock because it's more accurate. In 1884, an international conference established 24 time zones. 12 are east of the prime meridian and 12 are west of it. The international dateline is directly opposite of the prime meridian, and that's what separates the east time zones from the west one. In time zones for the U.S., we have several. We have Eastern, Central, Mountain, Pacific, Alaska, and Hawaii Aleutian. The Aleutian is that island chain in Alaska. We are in Eastern, though the Central time zone is not very far from us. It does split up in Kentucky. In each zone, the clocks are 1 hour earlier than the zone to the east. So when it is 4 p.m. here, it is 3 p.m. in the Central time zone. So I used to live very close to that line, and I'd have friends who would be like, well, we're meeting fast time or slow time, because if you're that close, you got to make sure you know which time you're actually referring to. The U.S. uses daylight savings time. The way to remember that is spring forward and fall back. In spring, we set our clocks forward an hour. In the fall, we set them back an hour. Okay, so if we remember from up here, each degree the Earth rotates takes 4 minutes. So on number 1, it wants to know how long it takes for it to rotate these amount of degrees. So we would just times these amount of degrees by 4 to get the amount of minutes. So for A, if it were 2 degrees, 2 times 4 is 8 minutes. It would take us 8 minutes to rotate 2 degrees. For 24, for C, we're going to have to solve it. 24 times 4. 4 times 4 is 16. 4 times 2 is 8, 9. 96 minutes, which if we remember our compound measurements, we can make that into 60 minutes is 1 hour. So 1 hour, and there'll be 36 minutes left over. So 1 hour, 36 minutes. If it is more than an hour, you should be converting it to hours and minutes. The only exception would be if it were exactly half. Like if it were 1 hour and 30 minutes, I would take 1.5 hours or 1.5 hours. Otherwise, you need to be telling me the amount of minutes. For E, it wants us to do 38 degrees. So 38 times 4. 8 times 4 is 32. 4 times 3 is 12, 13, 14, 15. 152 minutes. Well, I know that 1 hour is 60 minutes. 2 hours is 120 minutes. So 120. I would have 32 left over. This would be 2 hours, 32 minutes. For F, 100 degrees, well, 100 times 4 is 400 minutes. 400 divided by 60. I get rid of one of those zeros each because that's easier. 6 goes into 40. That would be 6 times 6 is 36. So 6 times. I have 4 left over. So I know that it's 6 hours. That would be 360 minutes. And I'd have 40 minutes left over. 6 hours and 40 minutes. Okay, for the next part, number 2, it gives us a chart it wants us to fill in of the American time zones. So we have the Hawaiian, Aleutian, the Alaskan, Pacific, Mountain, Central, and Eastern. The first one it does for us, it starts with 3 a.m. and goes all the way to 8 a.m. And then it gives us random ones, and we have to fill in the missing blanks. So for B, the one it gives us is 4:30 a.m. in Pacific time. Each time I go to the right one, I'm moving up by an hour. So when it's 4:30 a.m. in Pacific time, 5:30 a.m. in Mountain, 6:30 a.m. in Central, and 7:30 a.m. in Eastern. Then to the left, I would go back an hour. So this would be 3:30 a.m. in Alaskan and 2:30 a.m. in Hawaiian Aleutian. Okay, on C, it gives us 6:10 p.m. in Central Time. Now when it's 6:10 in Central Time, which is Western Kentucky, it would be 7:10 p.m. in Eastern Time, which is right here. Going to the left, be 5:10 p.m., 4:10 p.m. for Pacific. Alaskan would be 3:10 p.m. and Hawaiian Aleutian would be 2:10 p.m. Okay, for D, it gives us noon in Alaska, which would be to the left 11 a.m. for Hawaii Aleutian. For Pacific, we're getting an hour, so 1 p.m., 2 p.m., 3 p.m. for Central, and 4 p.m. for Eastern. If it is just on the hour, like 3 p.m., 4 p.m., I don't mind if you write it like that. If there are any minutes involved, then you need to make it look like the actual clock time, like 6:10 p.m., and so on. Okay, for E, it gives us a mountain time of 12:48 p.m. So if we're going to the right, we go up an hour. So Central Time will be 1:48 p.m. p.m. is in the afternoon. So if this were 1:48 a.m., that'd be midnight. This is around noon. Eastern would be 2:48 p.m. To the left, Pacific be 11:48 a.m. because now we're into the morning. 10:48 a.m. for Alaskan and 9:48 a.m. for Hawaii Aleutian. Time zones don't really affect us too much in our daily lives, but if you have loved ones in a different time zone, it's always good to know about what time it is there. I know when I lived in Alaska, which would have been this column, sometimes I would text a friend at, say, 10 p.m. at night, which would have been 11, 12, 1, 2 a.m. back home here in Kentucky. So sometimes they would get a little annoyed, so you have to just be aware of things like that. Okay, 3 is a word problem. 3A, Jeff left in Mountain Time at 3 p.m. and he traveled 5 hours to a city in Pacific Time. So what time did he arrive? So first, let's think about if he had stayed in that Mountain Time, then it would have been 8 p.m. Mountain Time when he was done traveling. Well, he went to Pacific Time. So 8 p.m. in Mountain Time, back an hour, would be 7 p.m. in Pacific Time. Okay, on 4, we have some times, and it wants to know what time that would have been for daylight savings time. So 5 p.m. would be 6 p.m. 12 noon would be 1 o'clock p.m. On 5A, we are converting from 35 degrees Celsius, and it wants to know what that temperature would be in Fahrenheit. So as a reminder, our formula for that is 9/5 C plus 32. So we have 9/5 times 35 over 1. We can simplify that. 5 goes into both, goes into it once, and goes into it 7 times. 9 times 7 is 63 over 1. 63 plus 32. 3 plus 2 is 5. 6 plus 3 is 9. So it would be 95 degrees Fahrenheit. For B, it gives us 88 degrees Fahrenheit and wants to know what that is in Celsius. So the formula for that is 5/9 times the quantity F minus 32. So the first thing, since that's in parentheses, is we subtract 88 minus 32. 8 minus 2 is 6. 8 minus 3 is 5. So then it becomes 5/9 times 56 over 1. Well, 56 is not divisible by 9. It is an even number, so it is divisible by 2, but 9 is not divisible by 2. And 5 plus 6 is 11, and 3 can't go into 11, so it's not divisible by 3 either. So we're going to have to multiply. So 56 times 5. 5 times 6 is 30. 5 times 5 is 25. 26, 27, 28. So it's going to be 280 over 9. Then we would divide. 280 divided by 9. 9 goes into 28 3 times. 27. Subtract is 1. Bring down my 0. 9 goes into 10 1 time. 1 times 9 is 9. Subtract 1. And it would keep doing that. So it'd be 31.1 repeating. Rounded to the nearest whole number would be 31 degrees Celsius. On 6, we have a few different algebraic expressions. This first one, 6a, is proportion x over 5 equals 4 over 9. When we have a proportion like this, we cross multiply. So 9 times x, or 9x, equals 5 times 4, which is 20. Then we would divide both sides by 9. So x equals 20 over 9. Sorry, I don't want to get you confused there. Numbers are awfully close together. So 20 over 9 doesn't go evenly, but I can make it at least a mixed number. 9 goes into 20 2 times. 9 times 2 is 18. So 20 minus 18 is 2. And my denominator say 9, so it'd be x equals 2 and 2/9. Okay, on B, x plus 4 equals 3 squared. Well, 3 squared, 3 times 3 is 9. So x plus 4 equals 9. Subtract 4 to get x by itself. X equals 9 minus 4, which is 5. On D, we have x over 8 equals 3. Well, we've multiplied both sides by 8. X equals 3 times 8, which is 24. And on 7, we have a few random problems. 7C is 23 is what percent of 115? To figure that out, I make a fraction. 23 over 115. Well, I know that 23 is a prime number, so I can't reduce that. I can't make 23, I can't find a number that goes into 23 and 115. But if I think about it, I know that 20 times 5 is 100, and 3 times 5 is 15. So 23 will go into 115, and it goes into it 5 times, so it'd be 1/5. So 1/5 as a percent, I know that 5 goes into 120 times, so it would equal 20%. I could have also gone the long way and to just gone straight to a decimal and did 23 divided by 115. But it works out a lot quicker, if I did it this way. Okay, D, it just wants us to reduce that fraction, 5/10 over 30. Well, these both have zeros, so I can divide both of those by 10. So it becomes 51 over 3. Well, after it is 51 over 3, I can reduce that again because 3 goes into 51. 5 plus 1 is 6. 6 is divisible by 3, so I know 51 is divisible by 3. So 51 goes into 3. 3 goes into 51. 3 into 5 is 1 time. Subtract, you get 2. Bring down your 1. 3 into 21 is 7 times. So D just equals 17. And then G, 3.5% of $12,000. Well, I'd start out with 3.5, and then I'd move my decimal 2, 1, 2, so 0.035 times 12,000. So times 0.035, 0, 0, 0. 5 times 2 is 10. 5 times 1 is 5, 6, 0, 0, 0, 0. 3 times 2 is 6. 3 times 1 is 3. 0, 0, 0, 0, 0, 0, 0. So 0, 0, 0, 0. 6 plus 6 is 12. 3 plus 1 is 4. We have 1, 2, 3 decimal points. 1, 2, 3. So my answer, 3.5% of $12,000 would be, don't forget your dollar sign, $420. I hope the time zones part makes sense, 6th grade. You don't really have to memorize what each time zone is at all times. You just have to know how far away it is from each other. And really, we're only going to be working with the American time zones because, well, those are the ones you would use more often, especially that Central and Eastern, because both of those are in Kentucky. If you have any questions, reach out to me on Jupiter or on Zoom. Stay safe. See you soon.